Hello everyone. So today I, Swati Verma, Assistant Professor at Calcutta's University School of Medical and Allied Sciences, Department of Pharmacy, shall be discussing with you about the calibration of UV visible spectrophotometer. How the calibration of UV visible spectrophotometer has been performed. So the first and the foremost thing we need to know is what is calibration. So the calibration is the act of ensuring that a method or instrument used in the measurement will produce your accurate result, that whatever the instrument we are using should gives us accurate results, as well as the results that we are obtaining should be reproducible. Calibration is performed using your primary reference standard. For each and every instrument calibration or for the calibration of glassware, we require a standard. The standard which is always taken for the calibration of that particular instrument. Now, what is the need of calibration? So when a specific time period is elapsed after a particular intervals of time duration, what we need to do is your calibration of that particular instrument so that it can gives us accurate result. When a specific operating hours has elapsed, it is mentioned in the brochure of each and every instrument that when you need to calibrate that particular instrument, after how many working hours you need to calibrate that. With the new instrument, whenever we install a particular instrument, the first thing that we need to do is the calibration of that particular instrument. When the observations that you are getting appear questionable, whenever you are performing an experiment, suppose the human error is 0%, so there must be a chances that some instrumental error is there. That particular instrumental error may be due to the calibration problem, that the instrument is not well calibrated. Moving forward, these are your certain instruments which we use for the calibration of to perform the UV visible spectrophotometer experiments. So this is your Shimadzu UV 1601, Shimadzu UV 2600, Perkin Lambda 650, Lamandia 3092. These are the following instruments which we can use to perform experiments on UV visible spectroscopy. Then what is the procedure for calibration? If we are performing the calibration of UV visible spectrophotometer, we need to look over the certain factors that we perform the calibration of certain parameters. Parameters like your control of wavelength, the wavelength scale we need to calibrate, the control of absorbance, then there comes the limit of stray light and the control of your resolution power. So these are your certain parameters that we need to calibrate before using your UV visible spectrophotometer. Also, we will check the slit width. The slit width of UV visible spectrophotometer also we check that what is the width over there. Then the maintenance of your spectrophotometer, what the precaution you need to take, and certain abbreviations. So first come here is the control of wavelength, how we can perform the calibration of your wavelength scale. So for this we require a particular standard. The standard that we use is your 1.4 molar perchloric acid. We prepare a solution of 1.4 molar perchloric acid which is used for the calibration of wavelength scale. Previously what we do is we take the filters of holmium perchlorate. Holmium perchlorate filters are available that we directly insert in the instrument and we calibrate that particular instrument. But now currently we use a solution of 1.4 molar perchloric acid, or you can use holmium perchlorate solution. What is the steps? First step is you will dissolve 1 gram of holmium oxide in 1.4 molar perchloric acid with the aid of heating on water bath. You will heat this particular solution over the water bath. After heating, you will cool it and dilute to 25 ml with the same solvent. After that, when the solution is completely prepared, you will record its spectrum. and the wavelength, the scale that you will choose is your 200 to 600 using your 1.4 molar perchloric acid as your reference solution. These are your certain wavelength ranges that should be obtained whenever you are performing a scanning. That first is your 241.15. The tolerance range should be 240 to 15 nanometer to 240 to 15 nanometer. There is a certain tolerance range that within this particular range the value should lie. Second 287.15 nanometer, third 361.5 nanometer, and then 536.3 nanometer. So these are your certain wavelength ranges where the maxima should be obtained. The value of absorbance should be high at these particular wavelength ranges with the tolerance range of this particular nanometers. Whatever the values we are taking, whatever the method we are using for the calibration, that we obey your IP. According to your IP, the instrument is calibrated. Whatever the method is written in your pharmacopoeias, your IP, your British pharmacopoeia, USP, we follow the same procedure for the calibration. Then the wavelength accuracy. So here is your diagram which is representing your wavelength scale and the absorbance. This should be your wavelength which you obtain like this. You need to have the graph. But if you are getting a wavelength ranges over this absorbance at a particular wavelength, either you are getting higher or either you are getting lower. Suppose at a particular wavelength like 240, the absorbance value should be 0.6, but you are getting absorbance value 0.8 or either you are getting absorbance value of 0.4. So in both the cases we observe certain shifts in the wavelength ranges that is due to your that the instrument is not properly calibrated. Either we observe a shift towards your positive side, that is your towards your longer wavelength, or we observe a shift towards your negative side, that is towards your shorter wavelength. So by this we can observe that whether our instrument is calibrated or not. Then comes to your control of observance. So in control of observance, what we do, we check that the absorbance that you are getting of a particular solution is correct or not. For this also we require standard. The standard that we use is your potassium dichromate. So whenever you perform the calibration of absorbance scale, the standard that you will use is your potassium dichromate. So you will weigh 57 to 63 milligram of potassium dichromate as your primary standard, and you will transfer it to 1000 ml volumetric flask. After that, you will dissolve in 0.005 molar sulfuric acid and make up to the mark. Whatever the volumetric flask you are taking, in this case you are taking 1000 ml volumetric flask, so you will make up the volume up to 1000 ml. Now you will measure the absorbance of this particular solution. For measuring the absorbance, we require a particular wavelength. The wavelength is specific. So we will measure the absorbance of this particular solution at a wavelength of 235 nanometer, 257 nanometer, 313 nanometer and 350 nanometer using your 0.005 molar sulfuric acid as reference. So the reference solution that you will put in your reference cuvette is 0.005 molar sulfuric acid, and in the sample cell you will place your solution which you have prepared of potassium dichromate, and you will measure the absorbance at your 235, 257, 313 and 350 nanometer. Now for visible region, we will use the wavelength range of 430 nanometer. We know that the visible region starts from 400 nanometer. So the wavelength range that we will take is your 430 nanometer. Now we will calculate the specific absorbance. So the value of A 1% 1 centimeter that you will calculate by using the formula absorbance into 100 divided by weight in gram into 100. So whatever absorbance you will get, you will put that particular absorbance over here, multiply by 100, then the weight of your potassium dichromate that you have taken, you will put that particular weight in this over here and multiply it by 100. So you will get a value of A 1% 1 centimeter. 1% is your concentration, 1 centimeter is the path length of your cuvette that you are using. Like this, you will calculate a 1%, 1 centimeter values for different wavelength ranges, and you will check that whether you are getting the absorbance value within the range or within the tolerance range. So for 235 the value should be 124.5 and the maximum tolerance is 122.9 to 126.2. At 257 you should get an absorbance value of 144.0 with a maximum tolerance of 142.8 to 145.7. At 313 the absorbance value should be 48.6 with a maximum tolerance of 47.0 to 50.3. At 350 the absorbance value should be 106.6 with a maximum tolerance of 104.9 to 108.2. Similarly at 430 the absorbance value should be 15.9 with the maximum tolerance of 15.7 to 16.1. Then comes to the limit of stray light. So we will check whether the stray light is present in our instrument or not. Stray light is basically an unwanted light which is present in your instrument. That particular light can be generated by various means, like it can be generated by your internal reflections occurring inside the cell, or it may be due to your extra light, outside light coming into your instrument. So to check the stray light present in your instrument, you will prepare a solution of 1.2% weight by volume potassium chloride and you will dissolve it into 15 ml distilled water. Second step, what you will do, you will measure the absorbance of your 1.2% volume by volume potassium chloride solution in your 1 centimeter path length cell over a wavelength range of 200 nanometer. Now the absorbance that you are getting should be more than 2. The absorbance at your 200 nanometer should be more than 2. If it is less than 2, then the stray light is present in that particular instrument. Basically, stray light is producing a negative deviation. So the absorbance value that you will get is lesser. Then comes to the control of resolution power. So for that you will prepare a solution of 0.02% volume by volume toluene and hexane. You will record a spectrum of 0.002% volume by volume toluene and hexane from 250 nanometer to 300 nanometer, in which you will use hexane as your reference. The absorbance you will record at 269 nanometer and 266 nanometer. This is your lower wavelength range, this is your higher wavelength range, and then you will calculate the ratio, that is maxima divided by minima. Whatever absorbance value you are getting at 269 nanometer, you will divide that particular value to the value you will obtain at 266 nanometer and you will find out the ratio. Now what is about maintenance of a particular instrument. When the instrument not produce calibrated result, it should be labeled as faulty and should be repaired by service engineer of instrument. So whatever the results you are expecting, if you are not getting that particular results, then you can name that particular instrument as faulty. Now what are the various precautions? The instrument should be always free from dust. You will need to place an instrument away from your possible magnetic and electric field, as you know that UV visible radiation is having electric and magnetic field and that particular field can interact with it. You will avoid the places while vibration can exist, because vibrations can lead to excitation. To extend the life of lamp source, you need to power them only when required. The temperature of the solution should not differ by 0.5%, otherwise the absorbance value that you will calculate will not be correct. This is a master copy of the record which is generated in your Devansh Testing and Research Laboratory. Like this, we obtain a calibration report. This is the example of a particular report generated in the industry.